Hi, this is the second video about learning probability. In this video, we'd like to talk about a challenging idea, the law of large numbers, and also using a simulation approach with students. What is the law of large numbers? The relative frequency of an event becomes a closer approximation of the actual probability, the theoretical probability, as the size of the data set increases. What are we talking about? Let's take a look at flipping a coin for an example. As we look at the relative frequency, the actual outcomes of flipping a coin, like this: tails, heads, tails, tails, heads, heads. Uh, it may not be close to 50-50 for heads initially. However, as the size of the data set increases, the more times we flip it, the closer that probability is going to tend to be toward the 50% heads that we would expect. Students experience a tension between what they tend to experience and theoretical probability because their experience tends to be on a small data set. So they may only flip a coin a few times. Let's say they only flipped a coin a few times and it turned out like this. They might believe that there's something wrong with that coin. However, in the long run, we would see a better balance between tails and heads. So this is why it can be hard for students to understand this. They need time with hands-on random devices and time tracking results in order to see the law of large numbers in action. So we can't just ask them to flip a coin a few times. They need time to flip a coin many, many times and track those results to get a sense of how this works in action. They need to discuss the differences between short-term and long-term results. Why is it not a problem with this coin that we got 10, 11, 12 tails in a row? Because on the larger scale, we've got a balance between things. They also need a chance to look for flaws in reasoning that doesn't consider the law of large numbers. If you only flipped a coin 10 times and saw 10 tails, should you throw it out? There's a flaw in that reasoning because we're not thinking about the large numbers. Using a simulation approach can actually help students develop some of that sense of the law of large numbers because it includes a lot of trials. There are significant advantages to using an empirical approach where students are actually carrying out trials. It's a real way that people solve problems in the real world, and so it's good for them to learn about that. It's more intuitive than theoretical, which sometimes can be confusing to students and not make a lot of intuitive sense to them. It eliminates guessing and wondering without any ability to check. Let's say I asked you what's the probability of rolling a 7 on this strange-looking die here. You could guess something and say, well, I think it should be this. On the other hand, if I say roll it a lot of times and track how many 7s you get total out of all, you now don't have to guess. You can actually see what's happening. It provides some grounding for moving toward that theoretical discussion that you need. It can help students see the law of large numbers in action as they do a lot of trials, and it can be more engaging. Just asking students to spit out probabilities theoretically can sometimes be dull to students, whereas getting their hands on and trying things out can be more engaging. How do we actually have students conduct a simulation? Well, usually it's a lot more complicated than just rolling a die. We might be asking some more interesting and sophisticated questions like this example. What's the probability that two students in class were born on the same month? How could we do that? First thing to do is to identify key components and assumptions of the problem. So what's the key component here? We're trying to decide what month students were born in. So there's the key. What are some assumptions of the problem? Well, we could assume that that the probability of being born in any month is equal. Now, that might not be totally true because there's a few more days in some months and a few less, but we can make that assumption for this problem and feel fairly confident that it's a pretty good simulation. Well, then we need to determine a trial. What is a trial for this? Well, it would be rolling or somehow determining randomly the month for each person in class that they were born. And so then we want to do a whole bunch of trials. So let's say I could actually use this die because it has 12 sides. I roll one for each student in class and record the months that they were born. We do this over and over again, recording information to see what is the probability that we ended up with two of the same numbers as we roll these. And then we finally use our data to draw conclusions. So we've got a nice process that can carry students from beginning of facing a problem to trying to answer it, and that's the simulation approach. A lot of good advantages to using it.